Good evening. Today we're going to be talking about the sum rule. This will complete off all my different rules and processes for taking the derivatives of a function. There is one mistake I made in the difference rule video, and since these are basically brother videos, I'm going to go over that right now. Very little mistake at the end, but it is important. The derivative of the arc cotangent of theta I said was equal to 1 over 1 plus x. Not exactly. The derivative of the arc cotangent of theta is equal to negative 1 over 1 plus x. So, little bitty mistake. Part of being human. With that in mind, I'm going to go ahead and get started with the sum rule. I will have the notes, questions, and solutions all in the comments as a pinned link to a PDF if you want to look at that and follow along with me. If you want to go to when the questions start, usually questions start at around the 5-minute mark. So if you go ahead and skip there, I should be doing the questions, but I will also have that up in the comments. I will take my mistake that I had in the last video and I will pin that as a comment or put it in the description of my video. So let's say that we have a given function s of x that is equal to x raised to some number plus x raised to some other number. So let's go ahead and define our variables. So s of x is just simply the function that we will be using the sum rule on. X, on the other hand, will be our unknown variable. And n and m are just our given numbers. We'll call them any given number. And for the sake of this video, really for the purpose of this video, I'm going to say that n is not equal to m. Because if it is, you don't have a sum rule, you just have a power rule. Let's say that we have x squared plus x squared. Well, you don't need to use sum rule because we know that's 2x squared. If we have x plus 5x, we don't need to use sum rule because we know it's 6x. If we have x cubed minus 7x cubed, well, we know that's equal to negative 6x cubed. So for these, we wouldn't need to even, if they're equal, we don't need to use sum rules. Actually, just a power rule if you actually did that. Though that last one at the very, very bottom, it's still a power rule, but initially if you wanted to, that wouldn't have been sum, that would have been difference. So I'm going to say that they're not equal. So the definition of the sum rule is the derivative of this function will be equal to n times x raised to the n minus 1 plus m times x raised to the m minus 1. If you want to write down another notation, we can say that the derivative of this function with respect to x is equal to the derivative of x to the n with respect to x plus the derivative of x to the m with respect to x, which is equal to, you guessed it, n times x raised to the n minus 1 plus m times x to the m minus 1. You could use operators notation, but I don't like operators notation because it's a little bit weird. In case you're wondering what that one is, it's the big D one. Actually, okay, let me. It's the derivative, and then you have the s of x. Something like that. That's what operators notation would look like, but I don't use that one that often. So we're going to keep that there. We're going to look at some forms really quick. There we go. So some common forms that you might see. Let's say we have y is equal to x squared, x cubed. Let's say y is equal to 3x squared plus x. So we have y is equal to x squared minus 3x. Let's say we have y is equal to x plus 3 times x plus 7. Let's say we have y is equal to natural log of x over e to the x. And finally, let's say we have y is equal to 1 over the hyperbolic sine of x. Let's go through these. What would we do? Well, this one right here is a power rule. This one right here is a sum rule. This one is a difference rule. This one is a product rule. This one is a quotient rule. And this one is a reciprocal rule. So, if you're wondering what you would do to solve all of these independent ones, I have made separate videos on every single one of them. So, the sum rule, when I said it completed the series, I really didn't mean it. The only one I haven't done is the definition of a derivative. But it's the limit as delta h approaches 0 of f of x plus h minus f of x over delta h. Very, very important, but takes a long time. So we're not going to worry about that because we know the shortcuts. I know the shortcuts. If you want me to cover that in a future video, let me know and I will. But these are all the different forms that you would see. So if you're wondering what you would do to solve all these other ones, you can go watch those videos. I will be focusing on this one. And because I've made separate videos on them, I am not going to be going over those at all in this video. So with that in mind, let's get started with some practice questions. So let's start with question number 1. Question number 1 is y is equal to 2 plus 7. Disclaimer, this is my 1, and this is my 7. I don't always write straight, but I do try. I don't always spell things correctly, but I do try, so don't get on me too much if I messed up, but I will try my hardest on those. Well, we know that using the definition of a derivative that I just showed you, the derivative of a constant is 0. And essentially, it's 0 because it's not... The entire point of taking a derivative is to find the rate of change of a function in relation to something else. And there is no rate of change of a number because essentially, if you plot it, y is equal to 9. Well, really, y is equal to 9, right? So, it doesn't really do anything. If you look at it, it's a horizontal line. And if you think of what the rate is rise over run. There's no rise. It's 0. So it's 0 over this run. And 0 over any number is equal to 0. So the derivative of a constant is 0. When you think about it, the derivative and the slope, they're really similar. They really are, if you think about it. But if I get a request to do the definition of the derivative, which will be the only thing I wouldn't have covered after this, I will do that, and I will go in more depth with that. So, let's just go ahead and do this anyways. Y is equal to 9. The derivative of this function is equal to 0. And there you go. That is number 1. Relatively straightforward. Number 2, we have y is equal to x plus 3x squared. So this is, we can find the derivative of both of them independently and just add them together. Remember, over here, if we had y is equal to x of n plus x of m, y prime is equal to n times x of n minus 1 plus m of x of m minus 1. So over here, y prime will be equal to 1 plus 6x. You can rewrite it if you want to, so we can say our final answer is equal to 6x plus 1. And that is our answer to number 2. I'm going to keep this over here because I think this is fairly important. So until I accidentally erase it, and it's going to happen, I'm going to keep this up there because this is some important stuff. So let's go ahead and move on to question number 3. So for question number 3, we have y is equal to x squared plus 12x plus 36. Now I know you're probably thinking, well, I can factor that down because it's x plus 6 squared. Indeed you can, but if you write this as x plus 6 squared, and it is, but if you rewrite it as that, this is not a sum, that's a chain rule. That's a little bit more trouble than you'd really be willing to go through. If we do the shortcut, square the first one, x squared, 12x, 36. Yeah, it goes back to the original, so we know this is valid, right? But you don't want to do chain rule if you don't have to. It takes a little bit longer. So we're going to ignore this, and we're just going to do the sum rule. So the first derivative of y with respect to x will be equal to 2x to the 2 minus 1 plus 12x to the 1 minus 1 plus 0. Which means the first derivative of y with respect to x will be equal to 2x plus 12 times x to the 0. Well, anything to the power of 0 is 1. So plus 12 and plus 0. But I'm not going to write the plus 0. So this is our final answer. So let's go ahead and move on to question number 4. I'm trying to be very careful to not erase that, but it's probably going to happen later on, unfortunately. So for question number 4, we have y is equal to 9x plus 9. Well, we know one of our handy-dandy rules of taking derivatives, as stated over there, the derivative of a constant is 0. So the derivative of this function, dy dx, is equal to 9. And that is our answer for question number 4. For question number 5, we have y is equal to x cubed plus 64. So, true to our definition of the derivative, we know the derivative of a constant is 0, so that only leaves us with the x cubed that we have to find the derivative of. So y prime will be equal to the derivative of x cubed, and the derivative of x cubed is 3 times x raised to the 3 minus 1. Which is equal to 3x squared. And that is our answer for question 5. For question number 6, we have y is equal to e to the x plus the natural log of x. So this is an interesting one, because if you remember, if you have natural log of e to the power of x is equal to x, and if you have e to the natural log of x, that is also equal to x. But you're not allowed to say, well, if I have natural log of x over e to the x is 1 or something. That's not going to work. I know you might think it would, because you're like, well, x over x is 1, so this over this is, this over this would be 1, but if you just had natural log of x over e to the x, yeah, no, that's not going to happen. It's not going to work. Nice thought, though. So what you have to do instead, you just have to know the derivatives of both of them. Well, the derivative of e to the x is actually surprisingly complicated. The derivative of e to the x is e to the x. Not complicated in the sense of memorizing it, but complicated in the sense of people overthink it, and then before you know it, you write down something else. Like, well, e to the x, it has to be e to the x squared or something. So you'd be surprised at stuff that people write down. But surprisingly complicated. Sarcasm aside, the derivative of the natural log of x is equal to 1 over x. So you can do some fancy big boy algebra, and you can be like, well, I want to get the common denominator. So sure, you can do that. E to the x times x plus 1 over x. You can do that, but when you want to take the derivative of that, that's a quotient rule. Again, you don't want to do quotient rule if you don't have to. And I think quotient rule is relatively straightforward. In my opinion, I think it's even more straightforward than product rule. That doesn't mean I want to do it if I don't have to. If you leave it like this is just a product rule. Well, actually, it's not even a product rule. This part right here is a power rule. And this part right here is a reciprocal rule. So it's actually faster. I've covered that in separate videos, but that's what you do for number 6. So that is question number 6. Well, we knew it was going to happen eventually, so let's just go ahead. I need the space anyways for the last question. So I only have one question left for you guys, and it is question number 7. So for question number 7, we have y is equal to sine of theta plus cosine of theta. If you've watched my difference rule video, you know where I'm going with this. Plus tangent of theta plus cosecant of theta plus secant of theta plus cotangent of theta. And if you have watched my difference video, you know my reasoning is the same. The reason why I'm doing this is I don't think you would see this on a test per se, but I do think you would see something on the test that would ask you to find the derivative of one of these independently. So if we know the derivatives of all these, then we're fine. So this is a nice way for me to go over the derivatives of all of these different trig functions. So let's just do it all in one go. So the derivative of y with respect to x, this will also be our final answer. The grand finale of the video, if you will. The derivative of sine of theta is cosine of theta. We're going to take this slow because I would prefer not to make one mistake at the very end of my video. The derivative of cosine of theta is negative sine theta. The derivative of the tangent of theta is equal to the positive secant squared of theta. The derivative of cosecant of theta is equal to negative cosecant theta cotangent theta. The derivative of secant of theta is positive secant theta tangent theta. And lastly, the derivative of cotangent of theta is negative cosecant squared of theta. It's funny, when you look at this, it actually directly parallels, if you saw what I did in my difference rule video, it actually parallels each other. The derivatives of sine and cosine are positive and negative respectively, but then when you take the derivatives of their inverses, the cosecants and the secants, they're actually switched. The secant derivative is negative, and the cosecant derivative is negative, and the secant derivative is positive. And then the cotangent and tan switch. So that's actually a really nice parallel. I don't know if that's intentional, but that's just math. So this, let me double check. Sine, cosine. Yeah, so this is our final answer. So that's all I have for you guys for this particular video. So if you guys like the video, then you can leave me an idea for a future math tutorial video that I can cover later. But that's all I have for this one. Again, I will post a link in the comment section to a PDF file with my notes, questions, and solutions to it, so you can follow along with that if you'd like to. Thank you for watching. I hope you guys learned something, and I hope you guys have a nice day.